Welcome to all. Now, in the last class I told, next class I am starting ladder friction. Then suddenly I remembered one important question is pending in wedge friction. See here. That is finding the coefficient of friction. I will tell some little later. Now, the most important part of this question is this question, see, special question for wedge friction to test your mathematical knowledge and capacity. I will tell you here. You can write how good you are in mathematics or what is your mathematical capacity, thinking power, etc. will be tested now. It is not a big issue, it is a small thing. But right time it should come. See, when such a question comes in exam or anywhere, the decision made immediately is important. Sometimes little thinking you have to do, but not that you think for hours together or days together. And one more thing, remember, I will tell you, this mathematical part, mathematical concept which will decide your capacity or knowledge concept will be in the end when we solve equation to get mu. Till then it is this. Till then, this question is usual wedge friction question. So till then nothing. I will tell you at that time, or go through entire class. I will tell you now is the time to test your mathematical knowledge or capacity. Okay. So in the beginning, first part is usual. Okay. Now, something I want to tell. First, before that one, see, why this question came. When we started solving questions on friction, earlier also, if you remember, I solved question 5 to find force, etc., to prevent or to move, etc. For what? Horizontal plane, single block, horizontal plane, connected block, inclined plane, single block, inclined plane, connected block, etc. So many questions were solved. There, I also gave the question, find mu. It was there. But in wedge friction, I am not asked any question, finding mu. Later, when I go to ladder friction, again question is there, finding mu. Now, this question has significance. Problem is, see, first understand, finding mu. How many unknowns are there? First decide, see here. Here, two reactions, which one? R reaction and friction reaction is in terms of mu r. Okay, mu r. Here, base also, or I'll do one thing, somewhere here I'll write. This is for your structural knowledge, not mathematical. See, to understand correctly, see here, this question, I will explain in full detail. See, one here and later something like this. Okay, free body. See here. Here, this is block 1, block A, block B. Later, see, there is RA here, direction not required, and mu times RA, or mu times RA. Here, RAB, and see, actually direction I'll put here, this way. Okay, here it's going up, down, okay. And this is mu times RAB. Here, same force, reverse here, RBA, and friction is mu times RBA. Here one reaction, RB, and friction mu times RB. So, unknowns are, see here, RA RAB, and remember RAB, RBA, they are equal. This I told you so many times, equal. Then lastly, RB, and here mu times RA, one more is mu times here RAB, and mu times RB. Now, see, 1, 2, 3. Total normal reaction, 3 unknowns. See, you are applying for block A sigma Fy0 and sigma Fx0. Therefore, 2 equations. For block B also, sigma Fy0, sigma Fx0. Therefore, 2 equations. So, total equations you are applying 4, 2 at a time for each block. So, total 4 unknown possible. RA, RAB, RB are unknowns. Now, here see, here mu. If this is mu1, this is mu2, this is mu3, this question cannot be solved. Why? RA, RB, RA, RAB, RB, 3. Mu1, mu2, mu3, 6 unknowns. See, in all the earlier question, I used to give different mu here, but it was known value. See, that was not unknown, it was a known value. So what? Whatever mu they give, you put mu into RA. There is no problem, but mu is unknown. Already 3 normal reaction unknowns are there. So only 1 mu possible. Therefore, this question, they have to give your mu1 equal to mu2 equal to mu3 equal to mu, or they should tell relation between mu1, mu2, mu3. Usually what they will do is they should give mu1, mu2, mu3, they should connect it. They should write how mu1, mu2, mu3, what is the relation between them, so that all will be in terms of one variable. But therefore, this question, the one who set the question, here I only set the question, should know all this concept. That's why, see here, see, the block A is on the verge of getting lifted when a force of 14.723. I will tell you what is this 14.723 dot. See, I'll tell dot here. Why I wrote 14.723, I will tell it later. Anyway, for you, it is given in the question. Okay, that force is applied on block B as shown in figure. Then they told find coefficient of friction which can be considered to be same. See here, to be same for all contact surface. That is, if it is mu here, here also mu, and here also mu. Everywhere it is mu only. So now unknowns are, since all the contact surface mu is constant, same value, now unknowns are RA, RB, one RAB, RAB means RBA, both are same, and then lastly mu. 4 unknowns are there. Yes, no problem. Sigma Fy0, sigma Fx0, you are applying 2 times, total 4 times equations are applying. Therefore, question can be solved. Okay. Now, this is for your information. Why I am not given different mu's? See, if a person gives different mu's and asks you to solve, I will tell, first you solve. I will tell him, I will be your slave throughout your life. If you can solve this question by usual procedure, don't by giving any relation between the mu later, then you solve it, I will be your slave by using equilibrium conditions, I will be your slave throughout your life. He cannot solve. Okay, now, one very important, see, now, before we start solving this question, something I want to tell right here. Something I want to tell. Safety, something I want to tell. What? This is regarding that 14.723. How that number came, dot. See, of course, when you solve a question of this type, you cannot ask The person told, no, I found answer is 4. I applied a force, so when I increased the force to 14.723, it was on the verge of lifting. Who are you question me? Sir, why can't you give 15? It is my choice, he will tell. There is no rule that this way fractions, this way odd value cannot be given. Some number given. So, but here, there is a reason. And one more thing, that reason has something to do with the mathematical capacity of you and also me. Okay, now, what I have done is, what I have done before giving this question, is, I considered a question here. See, I considered a question. I considered a question of, see, (20 degrees), weight of this I took block A, this I took block B, weight of 16 kilonewton, and I took mu here 0.2. Here also I took mu 0.2. Even this contact surface also I took mu 0.2. Then I applied a force P. Kilonewton. Okay. I applied a force P. And this is question to myself only. Right here. This is, I consider, right here. But now, you also solve. Somewhere outside. Outside means not outside the room. In your regular book, not in this question. You make one more question. You write, an extra question is giving, which he is telling why he is giving. So you take a rough sheet. Actually, this question already solved. Question is find value of P when, find P when block A is on the verge of getting lifted up. This is a question. But since I considered, I did not write anything. I directly solved. Within no time, I got a method. I can do faster. Anyway, this is a question. Now do one thing. You take a separate paper or do one thing. Somewhere outside, attach the paper. There, don't mix up this one. You write here. This is a question. And note, this question is already over in the beginning of the chapter. Wedge friction. See, at that time, this was inclined. Same was our question number 1, but with more difficulty. Why? This was inclined. So, cos sine resolution will come. Even P was also inclined there. See, this P was also inclined there. Don't see here. P and these 3 mu's were different at that time. So now a simple question you solve. And right here, when I solved, I got P equal to 14.723 kilonewton. 14.723 kilonewton. This is the answer I got. Therefore, when I set the question number 89, I put the same properties here. See, I forgot right here. This is 20 degrees. I forgot right. 20 degrees. I took the same question here, same weight, and 0.2 unknown, that is mu here, mu, and force, what I got, 14.723, I applied here. Therefore, That this question is, what is the value of P limit to get the limiting when the block is on the verge of getting lifted up? P came 14.723. At that time, the three friction coefficients all equal are 0.2. Now, since I am giving force of same force here, now you know how I got this force. Therefore, our question number 89, that is present question, your mu has to come 0.2, maybe 0.19999, 0.20001, that's okay because of approximation. See, when you calculate sine, cos, etc., some rounding off is there. Therefore, you should get 0.2. You have to get it. That is your mathematical capacity, because there is some problem. I will tell later. When your mathematical capacity is counted, I will tell, see, when you form the equation, usual solution. Okay. Now I will do one thing. This question I already solved. It took me not more than 1.5 or 2 minutes. Why? Because some inclination is there. I think maybe 1 minute, 2 minutes. Okay. You take 10 minutes, solve. The solution is already made. I solved in a rough sheet. But now, since for those who are interested, this solution, only this solution, what I did is, before recording now, see, before recording the class, starting the class now, I recorded there on the board, roughly, very no explanation, like what, this is a friction, this way friction, how many times I have to tell, see, no, everything is over. So, what I did was, on the board I wrote a brief solution, very brief solution, and got the value of P. Okay, that what I am doing is already recorded. Now I am going to close this recording, and next I am inserting that one. So when you watch, now you can see that solution for this question, where final answer is 14.723. At that time, all the three contact surface mu is 0.2. Therefore, our main question now, finding mu for this question, same force given, answer has to come to 0.2. Okay. And that one, I did not come to the board. I wrote on the board. Then I went near the camera. No mic wire, nothing. I did not put the mic also. I talked there. See, this is the solution for that one. Go through this one, solve this one, already you know it, etc. So I am inserting. So there is a voice difference is there. Voice will not be this much clarity, but it will be clear. I saw it. If I stand very near to camera, voice is clear. Suddenly you can feel some slight change in the voice. Yes, because it is recorded. That board, from I think more than 20 seconds is there. I recorded that one. I am inserting it. Okay, now I will stop this, not stop the class. This recording so far what I have done, I will stop. Then I will continue once again recording. Later editing this one, that pre-recorded solution, then continue. You know, that is not your problem. I will once again come back here. I will tell, just now you saw the solution. Solve it. So now commitment. Mu has to come 0.2. I will tell you mathematical problem for you, and this question also I will tell you my mathematical capacity, something connected with my mathematical capacity also. Briefly I will tell you. So therefore I will close this recording now and insert that pre-recorded one, then again continue. Actually when you watch, suddenly that will come now. Okay. Just now I wrote a question on the board. I told you to solve yourself only. That is finding that P when mu is given 0.2. I told the reason for you. Now, you can see the solution. Nothing I am explaining, because why? This is already over earlier. How many times? Therefore, now I will once again go back to our question of today's class, that is, as I told, mathematical problem. Okay, I'll continue. So, I am continuing. Just now, in between, I inserted that point around 25-30 seconds video where solution given. Answer we got how much? 14.723. So now for this question, it is commitment, or we have to get mu equal to 0.2. Okay. Now solution for present question 89. Let mu be coefficient of friction which is same for all contact surface given in the question. Okay. Everywhere mu. Okay. Now I need not solve. I will tell once again. See, free diagrams A and B. You write here free body of A, free body of B. A 16 down. This surface, contact surface, RA without suffix. When you apply the load here, this weight tries to goes up, friction down, mu RA. Then normal reaction for A from B, RAB. When you apply the force here, three concepts, this is class number 75 told. See, when you apply the force here on this one, it will rub this. See, the force here will what? See, this will upper block, it will rub like this. So when this moves right side, upper block will get a rubbing force of mu RAB this way, not this way. Or one more thing, see here. Again somebody will tell, sir, this you told 10-15 times earlier in class 75. Okay, see here. When this B goes this way, relatively A looks like going left side. It looks like relatively going to left side. So friction is right side. Or friction for the upper block is in somewhat same direction, not exactly horizontal, component wise, see, component wise, same as the movement of the B wedge. So if this is moving right side, it is like this. Or in case it's moving left side, it is this way. This is all I told earlier. Class 75, hundreds of time told. Real concept, practical aspect, crude method, practical example also. Okay, this is free body of A. Free body of B, see here. P, 14.723. RAB up means RBA down. Mu RAB this way means mu RBA this way. This is known for you, RB and mu RB. Now, I won't waste time now, see. Remember, this also I told hundreds of times. These are mutual, see. These two are equal. And even these two are also equal, very important. These two are also equal. So, earlier, first we solved A, got RAB, mu RAB, got RAB. Then when I consider here that RBA, we wrote equal to RAB. See, you can write here RBA equal to what? RAB. And mu RBA equal to mu RAB. This is told thousands of times. Remember, this is a free body for this. Now do one thing. This is to understand. See, examination point of view, you need not write. You start right here. Consider free body of A and consider equilibrium. This one later. This is to understand. Now see, now I am starting solution. When I put A, consider A, I will put this diagram. When I consider B, I will put this diagram. I will rub it now. Now I will write everything. Little I will write earlier and save the time, because time also counts. Now solution starts. See, x, x, y, y, you know it. Consider free body of block A and also consider equilibrium. You write that. This I am not writing dash, dash, dash because so many times I written. See, weight 16 kilonewton. Normal, this red color is contact surface. This contact surface RA. This is going up, friction down. Oh, this all I already explained for you. Okay, RAB, mu RAB here. Then 20 degrees here, for this one 20 degree with XX, for this one 70 degrees. Sigma Fy0 plus RAB sin 70 minus mu RAB sin 20 minus mu RA minus 16 equal to 0, equation number 1. Then sigma Fx0 plus RAB cos 70 plus mu RAB cos 20 minus RA equal to 0, equation number 2. Make a note here. Make a note here. In all the previous question, mu is known to you. It can be same mu or different mu. See, this can be different mu, but values are known. Therefore, in all the previous questions, RAB, 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 RA. See, two unknowns are there. RAB and RA, mu is known. You solve the simultaneous equation and get the value of RAB and RA. Then, when you consider block B, when you put this normal reaction RBA, you write RAB and here write whatever answer you got. And this friction mu RBA, you write equal to mu RB and RAB is known, substitute and get the value. So for the block B, unknowns are RB, mu is known, RB and that unknown P. In all the earlier question, unknown was P. You write a note. Okay, now, but unfortunately here, this is RAB, then mu and RA. Three unknowns are there. We can't solve. So we have to wait for some time. Let it be there. Consider free body of B and equilibrium. Okay, see. RAB this way is RBA this way. Friction mu RAB this way means mu RBA this way. But write RBA equal to RAB. Otherwise, what will happen? Again, new unknown will come. See, this RAB, RBA is RAB. This RAB only. To save the time, instead of see, earlier all, this was known values. So, this RBA equal to RAB and this mu RBA equal to mu RAB, write this way. So, when you write the equation, use this once again RAB only. Do not consider RBA as unknown. Okay, start. Sigma Fy0 minus, see, not RBA, minus RAB sin 70, or if you write RBA sin 70, then replace RBA by RAB. Stop that way. We wrote it here, see, minus RAB sin 70 plus mu RAB sin 20 plus RB. What is one? Oh, this is sigma Fx0, Fy0, okay, equal to 0. What is this? I put horizontal force there. That is actually, why? Because there's a reason. Anybody can make out why reason. Usually in all the questions, we first put sigma Fx0. Only for friction chapter, sigma Fy first is advantageous. That's why sigma Fy0. So I thought, first equation, no, sigma Fx, okay, 0. Equation number 3. Then sigma Fx0, right side positive, see, minus RAB cos 70 minus mu RAB cos 20 minus mu RB plus 14.7230, equation number 4. Okay, now I will do one thing. Now, right here, now, 4 unknowns. Which one? See, count here. RAB, comma, mu, then RA, that is from that side. And here, mu is already over, RB and RB. Why? Mu is already taken. So RAB, mu, RA, and here other three are here. Extra is RB. 4 unknowns, and we have 4 equations. Therefore, solve and get mu. Get mu. I told you answer should be 0.2. Okay, now to help you, I will do one thing. I will rub this one and write the equation once again here, because usually when you write the equation for, see, you cannot solve by calculator directly. That's why it is always better to put the constant on right side. So I'll neatly put here 4 equations. See, I'll neatly put I'll rub everything now. I'll neatly put the 4 equations. Then I'll explain something for you. See. Therefore, see. Okay, this all gone. Therefore, I'll write here. Therefore, the 4 equations are, see, start here. Unknown. RAB, fair copy. Okay, I'll do one thing now. I will write and then start recording. Why waste time? Okay, equation 1, see, I wrote once again everything so that neatly, see, this 16 equal to 16. Why? Usually constant, we want right side. See, that's the usual format. Okay, unknown left side, constant right side. See here. RAB cos 70, mu RAB cos 20, minus RA equal to 0, minus RAB sin 70, plus mu RAB sin 20, plus RB equal to 0, correct? Minus RAB cos 70, minus mu RAB cos 20, equal to, take that side, minus 14.723. Okay. Now, why I am so careful? In spite of being so careful, in case if any plus minus sign is interchanged, etc., you correct it. My responsibility is principle, not calculation. Okay, now, very, very important. See. I write here. See, very important here. Here I write, red color I write. Somehow solve and get mu equal to answer 0.2. That is the answer. This is the final answer. Answer for the question. Answer for the question. Get mu equal to 0.2. See, not exactly 0.2, 0.200 something or 0.1999 something is okay because of approximation. See, later when you substitute for sin 20, but better, see, better throughout solution use 4 decimal accuracy. 4 decimal accuracy. If you get this, when you do sin 70, see how much you are getting. Where is the calculator here? I don't have calculator here. Okay, sin 70, whatever you get, right up to 4 decimal. Okay, that I don't have to tell. So that accuracy is more. Okay, now is the time where, right here, where your mathematical knowledge, you write here, where your mathematical knowledge and capacity is tested. You write here, you write not your, you write my. Someone will tell, sir, what is this, sir? 4 unknown, 4 equation, I can solve. Solve it. See, I will tell you one thing. If 2 unknowns and 2 equations are there, say x and y in calculator, x and y. You go to equation mode, see, x and y, this way. Equation 1, equation 2, constant is there. Some equal to some constant. Okay. You go to equation mode, tell number of unknowns are 2, simultaneous equation 2, then type the coefficient, constant, take right side and type it. Same repeat, you get x and y. If 3 unknowns are there, say x, y, z. See, your unknown may be something else, but the calculator takes as x, y, z. x, y, z, equation 1, see, equal to some constant. X means some coefficient is there, x, y, z, and then 2 x, y, z equal to 3 equation. Press what? Simultaneous equation mode, simultaneous equation, some disturbance is there. It's early morning now, I don't know. Something they are doing. Okay, hope it is not disturbing. And then press, see, what will happen? Horizontally 3 blocks, equal to block will come. Type, 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 equal to type. Second round, second line. Type, 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 type. Solve. It will give x, y, z. Okay. If 4 unknowns are there, maximum calculator, only 3 unknown, you can't solve. Then the 4 unknown, you have to make it 3 unknown. Or some present day calculators are there where 4 unknowns are there. Say for example, x, y, z and one more, I don't know. Then it is not x, y, z, maybe a, b, c, d. I don't know what is that one. Okay, a, b, c, d. Because 4 are there. Imagine a, b, c, d, a, b, c, d, a, b, c, d, a, b, c, d equal to equation 1, equation 2, equation 3, equation 4. If anything is missing, write 0 there. Okay, now what to do? Equation mode, if it is there in the calculator, type, 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 type constant. That way, 4 rounds, get A, B, C, D. I don't know calculator, what is the name? Okay, some will tell, we will do it, sir. How you can do it? But remember, this unknown should be only unknowns here. Only what? Unknown should be there. You cannot have A, B here. See, you can have 3 x and y. See, you can solve. You can't solve if it is x, xy here, and if it is xy here and y here. No, calculator cannot solve it. So, or, see, to solve, what happens? RAB. See, mu RAB. RA. Unknowns are what? Unknowns are, see, here our unknowns are what? Our unknowns are RAB. See, you can write here. See, unknowns are RAB, then mu RAB, then RB, and one more RA is there, and RA and RB. See, mu is not independent, but here what is there? You can't type here because, see, RAB here, here RAB, here mu RAB, mu RAB, mu RAB, mu RAB, mu RA, see, RA is here with mu, here RA is there without mu, here RB is there, here RB is there with mu. It should be only, see, everywhere it should be RAB, 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 RAB. Mu RAB, mu RAB, mu RAB, mu RAB. But here, it should be what? It should be RA and, see, mu should not be there. See, now you can solve. Now you can solve using calculator. But with RA, mu is there. Therefore, you cannot solve this one using directly calculator. See, because RAB is okay. Actually, unknowns are RAB and mu, not mu RAB. See, unknowns are RAB and mu. It is mixed here. See, one minute. One place RAB is there, another place mu RAB is there. Suppose you take mu RAB as unknown, here problem will come. RARB, there also mu comes. So, direct calculator you cannot solve. Therefore, you have to use your mathematical concept. This will tell you how, or you can feel now or understand how much is your capacity in mathematics. Test it now. Okay. Solve. Now, 1 minute. I am not solving here. I will tell you what happened this question when I first took it, not now, maybe some 20 years earlier. Because nowadays, engineering mechanics class I am not taking for academic purpose, long back, maybe more than about 20 years earlier. When I took engineering mechanics class, friction, this question in the class I solved. I will tell what happened. I got the equation. I told, now you can solve. Suddenly I observed, oh, this is a problem is there. RAB. Okay, even if you take mu RAB as unknown also, no problem. But here, mu is here, mu is here. RA here, RB, RA here. Here RB is there, mu RB. Independently, four unknowns are not there. All mixed up. See, RAB is one unknown. Mu RAB is second unknown. Mu RA is one more unknown. Then RB is one more unknown. Mu RB is one more unknown. Oh, this is a problem. This creates a problem. Therefore, what I did was, see, I did not get panic. I have confidence in my mathematical capacity. I looked here. Maybe I will tell frankly I will admit, 2-3 minutes I looked. It took that much. I told everybody, wait, this never happened so far. Okay. First time I am also getting it in this way. Then, see, maybe maybe around 1.5 or 2 minutes. It took some time. See, that much time it took for me also. See, then I observed, okay, if I do that way, then, oh no, that will not work out. I decided something, that will not work out. Or, no. Then I decided, if I add 1 and 2, 3, this will cancel, mu RA and RB, one equation will come. If I add 2 and 3, because they are opposite, this will cancel, then RA and mu, that will give you mu RA and RB, this will give you RA and mu RB. Then I saw it, oh, it is no use. Once again, problem, back to square A. Then, again, no panic. I told them, I am giving solution, don't worry. Then, yes, oh yeah, this way me do. I am not telling you how. Yes, suddenly I got the answer. Yes, because I am not very weak in mathematics. I am quite strong. I know, see, if solution exists for engineering mechanics or strength of materials or structure analysis, matrix method, finite element method, design part I won't tell because so many approximation. I will give the solution. So far I never failed. I will not fail now. In future also I will not fail. Then, yes, I got it. I told students, now you try. Sir, how sir? You try. Next class, I will solve it. They told, okay sir, 1 minute. You should not think that I am telling next class because I don't know how to solve. Give a paper. I told them, give a paper. One of the students, okay, then. I went somewhere corner with nobody can observe. I write the steps there. Not solved it. How to solve I wrote there. Then I folded the paper and told one or two of you sign there. Why? Because otherwise tomorrow when I bring the sheet, I can't give the sheet to them. They will see the solution. I told you should not see solution. You should try. Sign there. Okay. One or two signed there. Okay. Folded. I put in the pocket. Next class, I will show you. I can't change now. Why? Their signature is there. Their signature is there. One or two signed there. This actually happened. But some of the students told, sir, not required, sir. If you tell you know how to solve, we know you know it, sir. They have that much confidence. Still I told, nobody should think, oh, sir got upset and could not solve. Actually, I will tell you, see, to decide how to solve, it took 1.5 minutes for me to decide. So that much time required. Why? I am not a mathematician. I am a structure engineer. I have mathematical background. So it took that much time. Okay, then next class, I solved. Then I gave the paper to him. See now what I wrote in the paper. What way I solved, same way was there. Okay, but they know that I can solve. Okay, now, remember, this is not difficult. Some tricks required. Your capacity means how you solve. How you solve. That is, see, I told you, test your mathematical knowledge and capacity. Okay, now I am going to end the class. Then someone will tell, sir, if you do that way, in the online class, how you know that you can solve? How you right now, after this class is over, I am rubbing the board either today or tomorrow. It's too late now. Today or tomorrow, I'll take a photo of these equations. Then I will write the equations here and solve and record it. But I will not upload it. Now I will tell you when I will upload it. Especially later, I will start one more playlist where I will tell pending solution for questions. This will happen now in future also. Even in strength of materials also. So many times I will give tricky questions. I will tell you solve. Solution I will upload in the special playlist. I will tell there engineering mechanics, class number so and so, part 4 friction, question 89. In the class I told you these 4 equations solve. If you are not solved, I am giving solution now. I will give it. But remember, there is a condition. See, means I will publish or upload the solution for this one. See, I told you answer has to come point 2. If it is not coming, if I am not able to solve, I will stop the teaching now. See, anyway, first of all, that will not happen. See, now condition is that you know my classes. It is you have not shared or publicity. I will not tell. Told others. You are not taking interest. You only go to class and leave it. So many people, they don't see full class. So such questions. See, first of all, somebody may tell later, sir, very easy, sir. Okay, easy. But timely idea should come. Timely idea should come. Okay. So therefore, you are not responding properly to me. See how much effort I am putting now. My age and my effort. And I want the entire world to utilize these classes. I know it is worth watching or worth going through. It is not a systematic course for engineering mechanics. After ladder friction, powerful one, strength of materials. See how much I will explain. Structural analysis, both determinate and intermediate. Later I will tell. Okay, then, therefore, condition is there. I will publish the answer for this question when today's class, this class will get at least 10,000 views. Okay, condition. I will tell one more thing. I have seen so many classes uploaded. Views are, see, 30K, 40K, 50K, 1 lakh views, 1.25 lakh views. Do you think my class is inferior to them? So many people will tell, sir, nowhere we can see this way. The only reason is it is not spread. So you should support my channel and this structural education. By seeing that, see, I should get motivated. For that, you should have give me support. I asked one more support. That is your choice. But this support, psychological support, or this support of what? Getting more views and more. So therefore, I will wait till I get 10,000 views. Plus one more condition is there. At least 100 comments should come where you should request for solution. See, some will tell, why should I request? See, a student will always request the teacher. He will not ask the teacher or order the teacher. I can order. But teacher and student relationship should be that way. Student should be polite. He should request. See, when you are learning from me, you won't feel you don't have to write request. Okay, please, something like that. Either please, okay, anything, comment section, you should write, please upload the solution for this one when 100 comment comes there. And also, number of views for this class, other class we will see later, touches 10,000, 10K, the 10K when it comes, that day, immediately, I will upload, I will wait till that day. So it is now for you, your side, to give little more moral support for me. Okay, then one more thing. Why I am not getting much views? Because I don't go for any cheap publicity or gimmick like that. See, I will tell something. I have seen teachers, I don't want to tell actually, online classes, teaching what? See, I don't want to do that one. See, now, what happens? Got it? Yes. They will start dancing, shouting. So much thing they will tell. What is that? I will tell. You are insulting the teaching community, teaching profession. It's a holy profession. A teacher should behave in a dignified manner. Cheap gimmicks all, it will not work out. And those people who shout, dance, what you call cry, etc., different body languages, I have found so many mistakes there. I don't want to comment there. So many mistakes there, blunders they have committed. You show me one blunder I committed here. Okay. But anyway, leave it. That is their personal. I don't want to comment. But I am actually not happy. See, I am not happy. That is overacting and what? Shouting like anything. You see somewhere, it is so horrible. It looks ugly and frustrating. Disgusting it looks. Okay. It's their choice. If they see this video, at least, it's not video, this class, I don't call video, at least they should know what I told is correct. It is their problem. Okay, now, when this is fulfilled, I'll give till that time, this will be unanswered by me. Next class, I am going to ladder friction. You start commenting, 100 requests should come and views should touch at least 10,000. It will take some time. Okay, we will meet in the next class. Ladder friction, closing part of friction, very interesting. As soon as that is over, I am waiting strength of materials. Okay, thank you.